All right, so let's look at this problem. So I want to construct the influence line for the reaction at B. You guys want to use the tabular method or the equation method?
Tabular.
It's a ball.
I'm gonna suggest the equation method for this. That's right. So let's go ahead and write on here. So I'm just going to use this as my free body diagram. So there's my reaction at B. This would be my reaction at A. And I'm going to put my unit load up here on the top at a distance x from the left. And it is now your job on this condition as a function of x to find the reaction at B. How would you do that? If I gave you any problem where you had two reactions and I wanted to find the reaction at B, what would you do? Sum the moments about A. So let's do that. So let's sum the moments about A and make sure it's in equilibrium. So what is the moment due to my unit load about A at any position x? Is it going to be a positive or negative moment using my sign convention? Negative. So there'll be minus the load, which is 1, times the distance, which is x. And the reaction at y is going to create what kind of moment about A? Positive or negative? Positive. And the force is By. And what's the moment arm? 5 feet. So solve for B. By looks like it is x divided by 5. So I just need to plot that. So I'll come down here and say on my ordinate that I want By as a function of the load. And I'll just bring these lines down. So there's B, and there's the end. So I just need to plot that. So what is the value of that? You can't really see that very well. Let me do it again. So what is the value of this function when x is equal to 0? 0. How about when x is equal to 5? 1. How about when x is equal to 10? 2. If you connect the dots, you should get that. So, if I had a truck that weighed 10,000 pounds and it was balanced on one wheel, a unicycle, hey, it's Cirque du Soleil. So we've got a really big Frenchman. He weighs 10,000 pounds. He's on a unicycle. Where would he go to create the biggest reaction at B? He would go right here. And it would be twice that weight. And that position is right here. So when this one goes all the way out here at the very edge, it's creating the maximum at B. That's it. So if you're designing a bridge that looked like this, and you need to know the reaction here to maybe design the footing or the foundation, you now know that it's going to be twice the load of any particular thing that goes across your structure, which could be a multi-wheel vehicle of different weights. And I'll show you how to handle that later. We're just drawing the influence line. And that's it. Problem's done.
Is this going to be on this test?
Not this problem, but something like it.
Oh.
I like this.
So since we're here, why not? What would be the reaction at A? How would you normally find the reaction at A once you found the reaction at B? Well, let's do that. Let's sum forces in the y direction. I think that's called equilibrium. We've done that a few times. So AY and BY are both acting up. That's positive in my sign convention. And then your unit load is down. So when you put BY in here and you solve for AY, what do you get? You get 1 minus BY. And what if I were to plot that? So this is on the ordinate, that's going to be AY as a function of X. There's our 2 points. So let's plot that. When X is 0, what do you get? You get 1. When X is 5, what do you get? 0. When X is 10, what do you get? You get minus 1. Now where do I go to create the maximum reaction at A? Actually, two positions. I could either be at A or all the way out here at the free end. One would create a reaction that was up, one would create a reaction that was down. And if I stood right at B, what would be my reaction at A? 0. What would be my reaction at B? 1. In fact, if I said AY plus BY, if I add these two together, what do I get everywhere? 1. Because AY plus BY has to be equal to 1 to balance the 1 applied. So it's kind of graphically adding them together. What do you think of that? That's pretty cool. Any questions about that one? That was a quickie. That was only 6 minutes.